This is a short movie to give you a demonstration of the ISWS Summer School 2023 demonstrator. It consists of 3 pages. The first page allows you to connect to MetaMask and Solid. The second page allows you to anchor some RDF to the blockchain. And the third page allows you to verify some anchored RDF data. Before you can use this demonstrator, you need to have installed MetaMask in your browser, and you need to have got yourself some Ether on one of the Ethereum test nets. You also need to create yourself a Solid account. Details of how to do all this are on the documentation that accompanies the code base for this demonstrator, which is linked to from the workshop website page. So I've got MetaMask installed, so let me connect. When you press the button, it'll pop it up and ask you to log in. So here it's chosen the lead account of my MetaMask wallet and put it on the screen for you so you can see it's connected. Before you run the demonstrator, do make sure that you've switched to one of the test networks. So next, you need to connect to your Solid account. Now we recommend in the documentation using Inrupt, but obviously if you have different places running Solid, you can have a Solid account anywhere. So here you need to put in the URL that is the one that you would connect to. In this case, it is the one shown, https logininrupt.com. So let me try that. Now asks me to log in. And then you get asked to allow the Summer School app to talk to your pod. Now it shows you your Solid Web ID. Inrupt have a different storage location than your ID location. So once you've logged in, if you go to their login page, it will give you the storage URL. Yeah, and it has a unique ID on the end. So you need to copy that in. Now, basically you're telling the rest of the demo where to read and write data for this demo too. So in my case, I know I created a subfolder in my pod for ISWS demos, so I'm going to put that on the end. And then here you can read existing files. And that just tells you if you've forgotten what files you already got. And I'm going to use some of these for the demo, so that's why I want to load in. If you change the end of this to other ones and press read, it'll just read those in. So it's not a pod browser as such, but it just gives you a little bit of in-demo access. And obviously you can look at the code to see how it's being read. So I'm just going to copy the example of RDF that I'm going to use while I'm on this page. Okay. So on the next tab, you can anchor some RDF. You can choose a local file and then read it in, and it'll put it in here. Or you can choose a URL from your pod and read that in instead. Or you can just paste some in. Either way, the anchor button is going to read it out of this box. And here, if you did read it in from outside or paste it in, you can also opt to save it to your Solid pod, and it shows you where it's going to save it to, and then you just give it a file name. Okay, I've got some data. I'm all ready to anchor. Now, what it's going to do is take this and pass it to the link chain library, and the link chain library will return some metadata, which is what is actually anchored on the blockchain. And it will also return a granular version verification, which means you'll be able to do triple verification. And it's then going to spit it out into this box. This might take a while. It depends on the size of the data that you're feeding into it. I've got very small data, so it shouldn't take long. Once it's done that, it'll pop up MetaMask, ready to create the smart contract on the blockchain with the hash of your anchored data. So it'll show you the cost. Obviously, you'll make sure you're on Sepalier, Gurley, or one of the test nets, and it's only using your test ETH, so it's not costing you anything as such. Confirm. And then obviously the block has to go and be mined on the test net. Now it's waiting to be mined. And you'll get a pop-up to tell you it's finished. And then you'll see the metadata spat out into this box. How long it takes depends on the speed. There we are, it's confirmed. I was going to say it depends on how fast the network's running at the time. So inside this box, you'll be given some JSON-LD, which you'll need for the verification step. So either copy it and save it into a local file or save it to Solid. So I'm going to test 3, I don't know what to call it. And it'll be JSON-LD, and it'll have 2 pieces of data on it. It will have the granular, as you can see at the top here. The first element is the granular verification, and the second element is the full verification of the data that was actually anchored on the blockchain. And you can actually verify with either of those, but we're going to use the granular. But for the purpose of demo, it'll take just the block it spits out here in on the verify page. So let's save that to Solid, and there it is saved. So I'm going to copy that because I'm going to use it on the next page. To load in for verification purposes. So if you go to this page now, to verify, it wants 2 things. It wants the original anchored data to check against, and it wants the verification metadata. Under the hood, as I said, you can send either of the anchored or the granular to it. Here I'm just going to paste in that and pull the whole lot out that as it was when I saved it to Solid. And let me just go and steal this as well because I want that data again. Again, you can paste it into the box, load it from a file. Okay, so it's got its 2 things. It's got the original data and it's got the verification metadata. Now, in this case, we're going to use the granular because I want to show you how you can check on per triple changes. So it's going to pull that out of this block and use it for verification, sending it to LinkChain. Now, you need the MetaMask turned on again because it has to read the smart contract to verify. So again, depending on the size of data that it's verifying, this can take more or less time. There we are, mine's nice and quick. So you'll get returned a JSON object with 2 things, verified and unverified triples. Now in this case, it verified them all. It said they were all as they were when it was anchored. Now if I choose to go and make a change somewhere, so let's change this to 99999, for example, right? So I've just made a change to one of the triples, and now I'm going to re-verify. It's going to go off. Okay, so it's sent back the massive verified. But you now have one unverified triple, and that's the one I modified because that is not as it was when it was stored on the